From my previous video for Form 5 Chapter 2 Electricity. From what we have stopped in my previous video, we talked about potential difference, where potential difference, the unit is called volt, and it's basically work done to bring a unit charge from one point to another, which is over the previous page. Bring a charge from one side to another. What would be the work done? You need to do work in order to bring a charge from one side to another, and that's a measurement for potential difference, or V. Says if you have 9 volt, meaning you need 9 joule to bring one charge from one point to another. And then the derivation of the equation, we have work done as a unit W, will therefore be equal to V times Q. And in order to find out charge, then charge is W over V, and that's also equals to IT, which is the rate change of voltage, change of current, and then you get equate them, and you were able to solve quite a few numbers of questions by now. So I hope you really have gone through the reading up to potential difference, and you have tried those questions, chapter by chapter question, of at least maybe 10 to 15 questions. Because in this video, oh yes, I'm going to show you an example. Over here, I have two plates, parallel plate. One is on the direct current, positive side on the left, and the right is the negative terminal for electric field. So what happened? The electric field will be actually pointing from positive to negative. This is where the electric field. What happened to the fire in the flame is it points to the left, because at the tip of this fire you have all the negative field in the flame and the positive at the base. So when you apply electric field, all the electrons at the tip will be attracted towards the positive side. So this is one of the experiments to bring a charge from one side to another. Okay, so it is not that any value you get this kind of shape. You need to provide sufficient work done. You need to bring sufficient work done in order to bring a charge from one side to another. So what's the work done to bring a charge over to the positive side? Then from that you need to provide sufficient energy. You need to work sufficient work over here. You turn the wheel in sufficient speed in order to get this effect. Okay, because what I'm going to do next is how I'm going to measure them. Okay, what's the work done from one plate to another? The measurement tool you call a voltmeter. Okay, you see one of those in your school laboratory, in one of the experiments performed in your coursework. You'll see a voltmeter, and the best way here I'm going to tell you is I'm going to show you how are you going to arrange a voltmeter. So one way to do it is if you have your load or some light bulb or some resistor. Let's say it's a load, or maybe it's a resistor. In order to find out the amount of work done to bring a charge from one side to another, all you need to do is you attach a voltmeter parallel to your load. Okay, so that when current pass through it, you'll be able to tell how many volt. Okay, so in any of this diagram in the future, in any question, voltmeter has to be parallel to your load or resistor, light bulb, etc. So one way, short notes, you need to connect parallel to the load. Load could be a light bulb or resistor. You want to measure the amount of work done to bring a unit charge. Okay. So it measure. What does it measure? It measure a potential difference. Okay, short form, meaning work done per unit charge, watt. Okay, and one characteristic about the voltmeter, the current, when you have a junction here, what happened? The current would have split. So what happened? The voltmeter are going to have very high resistance to prevent any charge from flowing into the voltmeter. Okay, high resistance, really high resistance, so that the current won't flow into here. So current only flow through the load, but not through the resistance. Because you may try to figure out, you may try to imagine what a current is like water flowing. Okay, water flow through a tube. What happens whenever you have a junction? Then it will split. Okay, but one way to stop them from splitting it into here is you stop it, isn't it? You put a resistance. You put some sand, sand normally, yeah, to block water from flowing into the junction, right? The same goes with electron. In order to prevent current from flowing through the voltmeter, one way is you increase this resistance. You make this voltmeter in such a way that it has very, very high resistance. Okay, that's a characteristic. So the next one is called ammeter, because voltmeter measures the potential difference, but how are you going to tell the amount of charge, right? So you use ammeter. So in order to get ammeter is you measure the amount of charge. So the amount of charge, it has to be in the system. Okay, so therefore it has to be in series ammeter. Okay, or along the circuit. So that when current flow from left to right, you flow through the load or resistor, and then at the same time you flow into the ammeter and pass through it, so that you're able to tell the amount of current. Okay, so therefore it has to connect along the circuit, or in series to the load. So this case is a resistor. Okay, so what does it measure? It measures ampere or current unit in ampere. Okay, Q is IT, so IQ is equal to IT, or from our definition, I is actually rate change of charge. So you measure the amount of charge per unit time. Okay. For characteristic, do you want current to flow through it? Yes. You want current to flow through your ammeter, so therefore your ammeter going to have very low. And we're going to have low resistance. Okay, so these are the characteristics. Maybe you want to put in a table to compare them, as in some short question answer. Right? You may pause this video, read through your reference or text. You are supposed to have it, read through it, so that you doesn't need to wait for next week. You may straight away do your revision on the spot. You may pause this video before you proceed to the next segment. Coming up next, we're going to introduce you some law called Ohm's Law. Okay. Now, Ohm's Law. What is Ohm's Law? Ohm's Law comes from V equals to IR. It's all about this equation. But what it said, it tells, okay? It says electric current, this one, electric current, because we are not talking about water current, that's why it's electric. Electric current, I, that flows through a conductor. Superconductor is direct proportional. Is directly proportional. Direct proportional to the potential difference. V. Okay? The one way to really put into a graph, you can tell this. For any copper base or any conductor, your potential difference versus current, where 0 is here. If you want to try to plot a curve or plot it, you increase the current over conductor and you measure the voltage. What happens is going to have a linear line where the gradient of this line is actually called resistance. Okay? So here, the unit for resistance is called ohm, symbol omega. Okay? So resistance is the gradient between gradient or ratio. So what's resistance? Based on this equation, will be actually a ratio, right? From here, resistance is a ratio of potential difference to the current. Okay? Or in a layman term, what is resistance of current? Okay? Resistance of current it's actually the ability. It's the ability of a conductor to resist the flow of electric current. Okay? So the mathematical way is actually a ratio between V to I. But one way to explain what is actually resistance is ability of a conductor to resist the flow of current. Okay? So in some objective question, they do they test you on the ability to use this curve. Say for example, one question from the past is it will ask you to sketch a curve for I versus R. How you will get a curve? Okay, so from the equation of V equals to IR, so you want it to be I and R, so what you do is you bring down the R, so your I will be actually V over R, or I is direct proportional to 1 over R. Okay, so if you if you want to plot into a curve in one of the experiment at school, so there are a few ways of doing. One way is you plot I versus R, where this is your 0, remember 0, inverse proportional, so therefore there will be a graph look like this, or curve where now current remain O, you plot 1 over R, okay, and then you will still get your linear, okay, in some objective questions. So I hope you get what does it mean by that. You may pause this video and then no need pause this video, you may proceed with the next one because not much to do, because next we're going to tell the factor. What are the factors affecting it? Okay, what are the factors? What are the factors that affects R? Okay, first of all, we talk about current flow, isn't it, over a conductor. So first one would be, if you have a tube with cross-sectional area, okay, of this diameter A, compared to with a tube so tiny with this cross-sectional diameter so small, which one do you think that the current would flow much more easily? Of course, would be the big cross-section area, because all the electron, you have the same amount of electron. Let's say you have 2, 4, 6, 8, 10. 10 electron drift through it so much easier as compared to this one here. Okay, so therefore, what are the factors that are affecting the resistance? First would be the cross-sectional area. Alright, and cross-sectional area of a conductor. What's the relationship? Yeah, good to know. Okay, of a graph. A graph. You have resistance versus area, cross-section area, 0. So meaning, bigger the area, smaller the resistance, right? So therefore, the graph will be inverse proportional. Okay. Second factor, cross-section area. Second factor, the length. The length of conductor. How is that so? Now, in some cases, if you are you've gone through some example, well, you have two lengths, says one in a coil. You coil it up, and conductor, the same cross-section area, but if you measure the lengthwise here to here, I think it's kind of like, obviously this one will be longer than this one, right? I mean in terms of length of conductor, because you curve it already, so the total length is more. So this one longer. So what happened? Normally you see this curve at a heater, because you want to generate heat. Resistance will generate heat. So what's the relationship? The longer the length, the higher is resistance. Current, oh no, we're talking about current, we're talking about length now. Higher the length, longer the length, greater the resistance is direct proportional. Direct proportional. Longer the length, greater the resistance. Okay. Then the third factor would be the type. The type of material. Okay. The type of material, I think, is rather hard to justify. It's just that one way to look at it would be the characteristics curve. You have voltage versus current. What happened? The gradient, right? The gradient would be different for different material. Says the gradient, this one is lower. Then maybe you have another type, copper, or maybe you have nichrome. Okay, so the material determines the resistance. So you say like nichrome. Nichrome normally use it for heating element because the gradient is very steep. Okay, as compared to copper. Okay, you may have a list of material reference from your reference text, but maybe another one is maybe I will talk about silver. Okay, silver is less. Okay, because the gradient. One way to interpret this graph is look at their gradient. Okay, the gradient is definitely less than copper, and this is a very steep gradient, right? Okay, so types of material, VOI curve, and this is how, by looking at the gradient, you tell its resistance. Then what's the fourth type? The fourth one is called temperature. Normally this kind of question will come in your objective, so you need to be careful of to really understand every single factor. I mean, not memorizing it, but you just need to understand it accordingly. So for example, you have resistance, you plot curve resistance versus temperature as in degrees C. So you would actually get a positive gradient kind of curve. Okay, meaning when you reduce this temperature, the resistance would reduce, but it won't touch at zero because for some reasons. Okay, why is that so? Sometimes later you get to learn this. It's called Phonon effect. Electron try to move from one side to another through a, says, I'm going to explain it briefly here. Let's say you have a conductor. Okay, electron try to flow, or current now. Current try to flow one side to another. What happened? When you heat it up, what happened? When you heat up, the molecule in the conductor will vibrate. When you start to have vibration, the electron will be hard to drift from one side to another. It prevented the correct drifting of the electron from one side to another, and therefore it increases the temperature. I mean, increases the resistance overall. Okay, so one way. So therefore, they have an equation for resistance. R is equals to, R is direct proportional to the length. So length is inverse proportional to the area. Okay, as in here, 1 and 2. Then another factor called resistivity. Okay, this is called resistivity. That depends on the characteristic of the material, like 3 and 4. Okay, so by looking at the resistivity, it's a unique value, quite unique value for material. So by looking at the resistivity, you basically tell what kind of pure material is it, whether it's alloy or what, you can't tell, but normally for single element, the resistivity would be like a DNA. Okay, so here, by analyzing this equation, what happened? When your length reduces, your R reduces. Or when your area increases, your resistance reduces, right? When it goes up, it comes down, okay? Inverse proportional. Before you pause this video and proceed to question doing or reading up your reference, I'm going to introduce you the next characteristic of a material called superconductor. Because earlier we mentioned about conductor. In superconductor, we just learn it by graph, perhaps. Okay. Previously, we have resistance. We have resistance versus temperature. It says direct proportional to it. What happened? You have a curve look like this. Now, what happened now is this superconductor, when the condition is right, you get zero resistance, and this is called the critical temperature. What is superconductor? Superconductor is when the temperature reaches the critical temperature of the material, you get no resistance. Okay? Where is a material with is a kind of material, it's a ceramic material actually. It's a material that will decrease, that will have no resistance, typically no resistance when the temperature reach the critical temperature. Now this is not a characteristic owned by most of the material, because normal material cannot achieve superconductor state. The only known to people today used for magnetic levitation. Okay, let's say for MRI, you have diagnostic tools. You need to achieve really high magnetic field, so you reduce the resistance of the copper wire, and then what happens is you get really high current flow, and then you get an image for MRI. Okay, or perhaps a computer chip. Yeah, you don't want to have resistance, then you get very fast computer. Okay, or one material, very famous material at research state here is called MgBr2. Okay, you may look for this. Oh, not Br, it's magnesium diboride, Mgb2. Okay, it's a material that known to achieve superconductor at near to room temperature, but it's not yet at room temperature, near to it. Okay, magnesium diboride is one of the material. You may look through your reference text, what's the application for superconductor, but one of it is called MRI, magnetic resonance inductor. Oh, magnetic resonance imaging. Okay, use magnetic field to get image from your brain. And then magnetic levitation for the fast train. Okay. I think that's all for now. You may pause this video and go through the questions relates to our famous resistance, resistor, yeah, the factor affecting it, the Ohms Law, okay, etc. And yeah, some question relates to voltmeter, ammeter. You need to really read through your reference text. I think it's about 10 or 15 pages. And also try, I think you need to try quite a lot, you know, on this part, Ohm's Law and factor affecting it, especially make use of this equation. I would recommend about 20 questions in a week time. You try to look for 20 questions in maybe from 2 to 3 publisher, using their own, their design questions, chapter by chapter question for Form 5 Chapter 2. I think that's all from now. I like those thumbs up button. I hope you press on thumbs up button and subscribe to my channel for more upcoming video. Thank you.